So I'm excited to be here today to talk about how AI really works. So I'm aiming to provide a conceptual understanding. So we're going to be looking at lots of examples without getting stuck too much in the weeds of mathematical equations. But first, I need to mention a common pitfall. When we run into something unfamiliar like AI, our tendency is to try and connect it to something we are familiar with. Most people don't know how AI thinks, so we project our understanding of human thinking onto the AI. We see AI anthropomorphized in popular media all the time. From The Evil Terminator to Wall-E and the Jetsons, all these movies have something in common. They anthropomorphize AI. They all have something else in common. They give the wrong representation of how AI works. Artificial intelligence doesn't work like human intelligence. If we want to really understand AI, we need to resist the temptation to transfer our understanding of humans onto the AI. Instead, we need to study the mechanics that underlie AI and build our understanding upon that foundation. So AI understands, thinks, and learns differently than humans. So in this section, we'll focus on picking apart the brain of AI to see how it really works. And once we understand AI, we'll see that those surprising examples like Kim Kardashian being viewed as a lump of coal or ChatGPT being tricked by certain phrases are not unexpected at all. By the end of this training, you'll understand the mechanism behind those examples, how to produce examples like those on your own, and most importantly, what you can do to start fixing them. So we'll begin our journey by learning about the fundamentals of AI. So this roadmap is really the distilled essence of how AI works. So AI thinks, learns, and understands. How do we decipher each of these pieces? So first, AI is a universal approximator using neural networks. So this is the mechanism that allows AI to think. Second, AI uses a mathematical method called gradient descent to learn from data. And lastly, we'll see that this process of thinking and learning doesn't guarantee understanding and often doesn't lead to understanding. Okay, so there's a lot of terms in here I'm sure many of you are unfamiliar with, so we're going to explore what all of this means over the course of today's presentation. So let's start by looking at an example. So we'll look at the process that AI goes through to fit a data set. So this is a chart of children of different ages and their corresponding height. So let's imagine you want to predict how tall a child would be at 40 months. Which is outside the data set here. So this data set only goes up to about 31 months. So we need to extrapolate out to make our prediction of how tall a child is. Our ability to make that prediction would start with trying to fit a pattern to the data. So let's see how an AI would fit a pattern to this data. So it'd start by picking some random line, let's say with a slope of 0. So that's this orange line going across the graph here. It's obviously not a very good estimate. To figure out the quality of the estimate, we measure the error in the prediction. So we look at each data point and we measure the difference between the predicted value in orange and the actual value in blue. And then we add all those errors together. So this is the important part. It's possible using a tool from calculus called the derivative to figure out which direction the line is supposed to move to reduce the error. So if we look at iteration 1 in the top corner, our orange line initially had a slope of 0, which is clearly too low. Children tend to grow over time, so the slope should be positive. So in iteration 1, the line will increase its slope. So the algorithm updates the slope to 1. But now, if you look at the line, you'll see that in this first iteration, the slope is too high. And now in the second iteration, the slope is too low. So then the next iteration, it does sort of the average of those. So it looks at the middle, slightly too high. So then in this final iteration, it reduces the slope down, and it gets about the best approximation you can get for this data. So this process would continue going until we get a pretty good answer, and we get 0.65 as a slope in this case. So this method of iteratively updating the weights using the derivative is called gradient descent. In this case, it allows us to make predictions by fitting a straight line to our data. It's fairly straightforward to fit a straight line to a data set. The real power of gradient descent is that it can be applied to any function. So gradient descent works even if I'm trying to fit a much more complicated model than a straight line to my data. So universal approximator is the term given to a class of functions that's capable of approximating any data set. So straight lines are not universal approximators. If you look at a graph like this one here, there's no straight line that will do a good job of approximating the data. You can probably see how a good approximation, you would need a parabolic shape. So here's what the straight line of best fit looks like. It doesn't do a very good job of approximating the data set, but if we use a universal approximator, we can get a much better approximation. So a universal approximator can fit a pattern, can fit any pattern. Gradient descent tells you how to fit a function to the data. And AI is a combination of those two things. So it's taking a universal approximator and using gradient descent. And when you combine those things together, you can fit a pattern to any data set. So AI is really just that process of fitting a pattern to any data set. And that's why you can apply AI to such a wide range of problems. For example, it's possible using gradient descent to fit a neural network to the task of recognizing objects in a photo or to translating text into another language. So let's go back to our height of children example. We can apply gradient descent with polynomials to get a closer fit than is possible with a straight line. So the blue line in this image is a polynomial fit, and it tracks the data more closely than the straight line does. So AI allows us to fit a pattern to the data set. But just because you fit a pattern to the data set doesn't mean you fit the right pattern. For example, the blue function fits the data better than any straight line from before. However, notice that the predictions shown in orange here actually predict that children decrease in height at around 30 months, and it predicts that children keep decreasing in height for a few months after. So even though it fits the data set better, it doesn't make a good prediction outside the data set. So AI will always fit a pattern to the data, but there's always lots of possible patterns you can fit to a data set, and only some of them will lead to a good prediction. So to recap, really all AI does is automatically fit a pattern to the data set. When we say AI is thinking, what's really happening is it's just evaluating a function. So the AI we designed to predict the height of children does its thinking by getting some input for the age, then going up to the blue curve and computing the output. Again, I'll emphasize, thinking for AI is not like thinking for humans. You can clearly see it's quite a different process. Now, for a small example, like this height of children's example, we definitely wouldn't call this graph intelligent. But as you scale up the examples and you add lots more dimensions of input and complexity, the predictions that the AI make can start to become so good that it feels like the function is intelligent in some way. So AI isn't anything magic or unfamiliar. It's actually a fairly simple computational process, but just scaled up to massive proportions. So again, thinking for AI means simply computing a function and nothing more. So as I've talked about before, the XY pairs we give to AI can be a very broad range of objects. So image generative AI, for instance, takes the same framework of fitting a function to a data set, but now the x-axis are words and the y-axis is an image. So we're going to figure out how that works in practice by doing a breakout section.
This is the exciting part where you guys get to get hands-on. We're actually going to use Firefly this time on the link here for Firefly. That will open up a page like this. We are encouraging you to do here is to try putting in, if you have a pet or an animal, put the name of the type of animal you have. And then you can do in the style of an impressionist painting, or you can try maybe your favorite artist. You might run into some copyright issues where it won't, it won't do certain artists. But give that a try right now. So I typed in a parrot in the style of Dolly. I don't have a parrot, but let's see what it might be like if it was in that style. So what you saw here was, one or more of the words didn't meet the user guideline. That's something that's new as copyright issues have become an issue. So let me change this to parrot in the style of surrealist painting instead. And we'll hit that again. And again, as Caleb mentioned here, what has happened is the AI has consumed a massive amount of words with image pairs, and it's finding these mixes and patterns of what it's basically interpolating in would be the combination of the two. So I'll go with this one here, so the next thing we're going to show is how you can begin to make some changes with the edit function. Now, the edit function allows you to do generative fill. So this is called in painting, and then there's also out painting. Now, what generative fill does is if we wanted to put, we want to change part of the image, we might say, okay, let's put a hat on this parrot. And so you click that button and erase that part. I'll give you guys a chance to do that. And then you can type in a prompt of what you might want to put in that image. And then we'll come back and demonstrate that for you in a moment. Okay, I typed in the term top hat, but you can see that the AI was able to take that word, fill in the space here, and what it was doing was it was using the rest of the image that's there as context. Now, you remember yesterday in the training where we showed where you copied the transcript and put that into the AI and then asked it questions about that you might have asked me. You were asking my content instead. That was using the context of the transcript to answer the questions. In the same way, this is using the context of the rest of the image to try to figure out how to bring this image in and make it look like it will be consistent or coherent with the rest of the image. So this is in painting, and there's a lot of cool things that you can do within painting and so forth. Next, we're going to show the idea of out painting. We'll click on, instead of insert, we're going to click expand. Now, what expand does is allows you to stretch the canvas. So let's say you had to resize different ads and you had a format that was a bit wider and you wanted to basically adapt the image to fill in that part. Here, I mean, I can just actually hit generate and it's going to take the rest of the image, see the blanks, excuse me, spots, and then it will fill in the rest of the image based upon you know, essentially resizing the ad for me based upon that canvas spot that I gave you. And you can see it stays pretty consistent with the images and the concepts as well. Now, another thing that you can do with expand, we can actually change the canvas altogether. And what I'm going to show you in this case is I'm going to show you if we didn't use any context overlap at all, like we tried to put this image here, and we typed in, try something like a 4th of July parade. And what you'll see in the generation is because there's almost no context overlap, the AI is using the prompt, but it has very little information as context to inform how to fill that prompt in. So we get, a flag here that doesn't really look all that consistent with any of the rest of the images. Now, if we had had a lot more overlap, here in this case, we will stretch this image up and we'll have the context essentially overlap this part here. Yeah, stretch this down here. Now, if we do that same 4th of July parade, the Gen AI is using this context much more heavily than we did before, where we just had a tiny sliver of it, the information. And now the 4th of July parade does feel much more consistent with the core image that we had before. So Fireflies is one of several Gen AI technologies that are out there. We have, DALL-E was the one that came out from OpenAI. They're deprecating their old one. They brought that into the paid version of 4.0. Gemini does some phenomenal things in this area as well. Meta does some wonderful things in this area as well. So there's a lot of really good capabilities. And I am so glad that you guys got to get hands-on with this. And I see the emoticons. I'm glad you guys have liked this hands-on exercise. I think I'm using the free version right now, I believe, of Adobe. So I think you can do up to a certain number here. But I highly encourage you guys to play around with it because this is part of the things that makes I think Gen AI that part of it exciting is, as Caleb said, from that very simple math of having words and objects connected together, you get this beautiful playground where you can do all kinds of really interesting things with it. Context is very important. We're going to be talking about that a lot, especially tomorrow as Caleb goes through some of prompt engineering and we work more on the large language models.
Yep. So now that you've seen a little bit about what AI image generation can do, I'm going to have everyone do a quick exercise. I'm going to give you a prompt and I want you to imagine what that looks like. So here's the prompt written here, 3 blocks stacked on top of each other, red block on top of a blue block with a green block on the bottom. So try and imagine that prompt in your mind's eye. Okay, so not too bad, right? Here's what AI got when it tried this. So AI gets relatively close, but it doesn't quite get it right. It either gets the color, number of blocks, or order wrong in all of these cases. And here's a more recent one with Gemini. This is March 31st. We still get the same kind of thing. It's getting a little bit closer, but still not all the way there. So if you've had any chance to play around with these image generation tools, you'll probably notice that it doesn't seem to do exactly what you want it to. So it probably takes a few tries to get it to do exactly what you're thinking of. So something to consider when using AI is how strongly can I influence its outputs? So a specific area where you can't steer AI is logical reasoning. So these image generation AIs don't have logical reasoning. For instance, if you ask it something like a baseball player without a bat, that's sort of too complicated of a sentence for the AI to understand. So there's this image here in the corner. I ask it for a baseball player without a bat, and it gives a baseball player with a bat. So that's because without requires a certain understanding of language that the AI doesn't have. It needs to understand how without is modifying the word bat. So the AI doesn't truly understand language at a deep level. It's just looking at the words and turning them into something that resembles what the words are, but not what they mean. Actually, it's kind of impressively bad that the AI gets baseball player without a bat wrong because there's only one player on the field at a time that has a bat. And somehow, if you ask it for a baseball player without a bat, it chooses just that one person. Now, as another example of AI struggling with logical reasoning, if I ask AI to create a picture of 3 solid red blocks, it doesn't do great with this, but it at least gets some of the answers correct. But if we change that to 2 plus 1 solid red blocks, now we get 2 blocks with the number 2 on them. So Dolly, in this case, isn't really interpreting your text. It's sort of just looking for the words and the correlations between those words. And it doesn't understand actually on its own how to convert between 2 plus 1 into 3. So keep in mind that you have a limited ability to control what AI produces, especially with these image generation AIs. So it's really hard to specify exactly how you want things. So connecting this back to the slides above, the AI will do a good job of matching the pattern from things in its data set. So an image of a chair, a table, baseball player, etc. But it doesn't really understand the concept. So trying to combine them in non-trivial ways, like placing them in certain positions or having multiple objects or baseball player without a bat, it often fails in those cases. And we can see here an example of GPT-4o. So even if we test these with the newest models, here we asked for 3 blue blocks and 2 plus 1 solid red blocks. We end up just getting 2 blue blocks and 2 red blocks. So even though there's been a lot of progress in these AI models and doing better with images, these problems still remain. I want to take a moment to share with you what you should take away from these examples I give in this presentation. So already I've given a number of examples of AI failing. So we talked about Kim Kardashian upside down being seen as a lump of coal yesterday, and these image generation AIs being unable to count up to 3. And these examples I present are meant to give you a glimpse of how AI thinks by analyzing when it fails. So the fact that generative AI struggles to draw 3 blocks illustrates that it's using patterns rather than logic and thinking to produce its answers. But nonetheless, if you throw enough computational power and training, you can get these AI to perform better. So GPT-4 can produce an image of 3 blocks stacked on top of each other. So that's with this image here, whereas DALL-E 2 wasn't really able to do that. It still doesn't succeed on if you ask it for 5 blocks, so GPT-4, maybe the joke is that it's up to being able to stack 4 blocks, but not up to 5, and maybe we'll get that with GPT-5. And again, so the point is not that AI is an unimpressive tool, but these examples are here to illustrate that AI is not thinking about the words in your prompt and understanding them and then drawing an image. It's instead using this advanced pattern matching that allows it to create images that seem to match with the language you use. And this technology is really powerful and has some great use cases, but it's important to understand that the AI really isn't understanding your prompt. So I'll pass it on to Rex to take us through a few examples.
So, Kayla, I really liked what you were describing about how earlier that's those words and correlations. If I think back to that XY chart, I can see that the different words and so forth, it does really well with that. As you said, it doesn't really understand the depth of the words. So even the image that you have here of create an image of 5 blocks, you've got 1, 2, 3, 4, 5, 6. I'm pretty sure I'm counting better than how much do they spend to build GPT-4? Yeah, so these things aren't perfect yet, and it's important to understand what it is doing, what it's not doing, so you can make responsible use of it. One of the things Caleb mentioned, the baseball bats, I do update this data every single time we do one of this training one. I rerun the prompts and see where they're at. Back in March, when we did the training, it was create an image of a baseball player without a bat. But if you look closely, it looks like he has an extra hand and it's on a bat. So we tried it again just on July 24th, create an image of a baseball player without a bat. And here is, and it basically gives us the message back. Here's an image of a baseball player standing in ready position, stance without a bat. If you need any adjustments, feel free to let me know. I don't know. Tell me what you think this is. Maybe don't answer. It's a family show. We'll just move on. But yeah, it's still not perfect. So if you try it with Adobe, it actually does better. I've been more impressed with Adobe. For example, it did say baseball player without a bat, and it did give me all these images of people with bats to start with. So I went back in and said, okay, well, let me erase it, just like you showed with in painting. And then I erased it, and the first time it came back and added something else in the hand. I tried it again, and I said, gave it the prompt, remove the bat. That one, and removed it. Now it just looks like a fist. And so you can get to the images that you want. When I try to have it do anything like building an infographic or anything complicated, that's not where its strength is. If it's something that's sort of more, as Caleb was saying before, about precision, AI isn't great at the precision. If it's generally in the spirit of that we're going after, great. If we're trying to take an ad that we already have and we upload that in and we're just trying to resize it, it can do great at that. But it's important to understand what it is doing, how it's doing it, so you understand its strengths and the weaknesses. Be sure not to mistake thinking that AI is sentient or really deeply understands, because that's not where we're at right now with this generation of technology.